Hi and welcome to Naval Tech Tinkerer. So in this episode I'm gonna start building a new battery pack since as you maybe saw in one of the previous ones, I had this big 5.4 kilowatt and it actually didn't even fit in my son's jet boat that I built in carbon fiber and Kevlar and wood and a lot of epoxy. But yeah, so I accidentally discharged this battery too much and I was a little bit in crisis in the autumn, and I thought, okay, what am I gonna do? And Tom from 186050 batteries reached out and said, hey, I have some really great ones, something that you might be able to build really quick. And that got me interested, so we agreed on a price, and I agreed, so I paid for these myself, but I got a nice discount, so thank you for that, Tom. And so what are these? Let's take a look. So here we go. I actually had an accident, and I want to talk about that a little bit. So I am buying used cells from 186050batteries.eu, and I live in Sweden, and well, batteries take a lot of resources from the earth, and yeah, I like buying the used ones. Usually you can buy really good ones for great price, and yeah. So what did I buy? Well, I bought these prismatic cells. They are 105. Well, let's take one out. So here we go. You can see them. They are 105 amp hours. So something special about these is that we have, you can see he's tested them, put a little bit of protocol on them, and but they are a bit special. When you buy usually these, what's it called, prismatic LFP cells, they're usually 1C rated. That means that I can use whatever energy is in there in 1 hour. These ones are 3C, so if it's 105 amp hours, I can draw 315 amps, and that's pretty awesome, especially since I'm trying to run a speedboat with these. So we had a snag during November, me and Tom, and that's the snag. They were damaged during shipping, and Tom took responsibility and said, okay, we talked about it, and he said, okay, tell me which one are broken and which one are not. There was only one that was not broken, sadly, so these ones are going straight to the recycling. And yeah, I had one which was okay, so 9 out of 10 were destroyed. So I'm gonna do the 10S battery, and yeah, what will this give me? So we're gonna go for 30 volts, or 30, what is it, 10 times 3.2 volts, which these ones are. This is LFP, and that will give me 32 volts times 105 amp hours. That approximately gives me like 3.3 kilowatt hours, 3.4 ish. I don't know, my math in head is not that great when it comes to these things, but yeah, it's that's pretty big actually. And the weight, yeah, they do weight more than NMC batteries, but in total this will still be like 7-8 kilos lighter than my previous 5.2 kilowatt battery, so that will still be nice. But the key thing here really is how you can build it. So I will have 10 instead of 400 and 440 cells. I had to check and test and all these things. Real time consuming. And here we just put them like side by side, and just do like plus to minus, minus to plus, plus to minus, minus to plus, with a pretty beefy copper bus bar in between that I'll have to build myself. But that also, and this also means they all have screws. I don't have to sit and weld, like it was like a million welds when I did it last time. I still love these LG MJ1s that I have. I think I have a few here in my, yeah, I have them there. I'm gonna use them for other things, so I still use them. But the price of these, well, I would actually say that the price that you're gonna buy them, if you buy them from 18650batteries.eu, it's gonna be pretty similar to the price that you will pay when you buy new ones. But they're not gonna be 3C rated. These will give 3 times as much power in the same amount of time than these new ones. So there are pros and cons to this. I am space limited. I need something that I can kind of hold, if you can imagine, like this, and walk away with. So yeah, I have my essentials here. Basically, I went to the supermarket and I bought cutting boards, and I bought 5. They cost like $2 a piece. So I got 2 of these plates that are then cut out with scissors. And what they're going to do is that when you put these LFP cells, you actually have to put them in compression. But if you think about how these batteries are built, the outside here is actually a negative pole. You can see this plastic little flimsy protection. If I would connect these in series, like imagine having one more here, and I connect the plus and the minus, and then the minus and the minus hits, this is going to be a big boom. And you don't want that. So I was planning actually to take something like this. This is a 3D printed ABS plastic. It's flame resistant. It's really good. But there's pores, and there's risk that some kind of, since I'm building a boat with this, that I would have, what do you call it? Some kind of water that actually bridge this. I really don't want that. So I went with the solid cutting board. I bought 5 of these for, yeah, what did it become? $10 US. And I cut these pieces. They're like 2 millimeters thick, which is kind of perfect. And I'm just going to place them like that in between. And why do we need them? Well, first it is also, you know, if they actually jump around a little bit, they might have a little bit tear on this plastic and they will short. And to protect that, we put this 2 millimeter solid plastic in between. And what more? Why do we have them? Well, we're going to have to put it into compression. I'm not going to follow best practices here, which is to create some kind of thing around it and kind of put everything in compression to push them really tightly, because they swell when you use them. Compared to the small 18650s, they swell because they have so much lithium and iron phosphate inside, so that they swell. And if you don't put them into compression, you can actually get into serious trouble. So I'm going to try to do what's minimum acceptable, and that is that I'm going to put them together with one sheet on each, like this. And then I'm going to put glass fiber tape around to kind of push them together. Later I might actually also put like something that actually puts it into proper compression. But then I need something to go from one side to there and then push it together. But I'm not going to do that as a first. I just want something that works, and this is, from all my research, acceptable for what I'm trying to do right now. Okay, so let's get them out and take a look how it will look like. So here we have them put in like mocked up how they would look like when they're actually in the battery pack. So much easier, am I right? It's like 10 cells. You don't have to weld. I just have to connect these together. So yeah. First there, then there, then there, then there, then there. And as with anything you work with batteries, you have to take real safety when you start connecting them in series. When they're single like this, they're safe as hell. They're 3.2 volts, I think. Let's check. But I just wanted to give you a little bit look how big it would be, like what I'm striving towards. So I want something that is like something easily to carry with one hand. And I put this little bag on the back. You can see it's a little bit wider, but it's still kind of nice sized, right? So if I bought new cells, like I could have probably bought 300 amp hour batteries, but they would be really, really big. And I'm not kidding you, that would have been like 60, 70 kilos. So like this. And I couldn't fit it in my son's boat. And also, any kilo you put in the boat will create more resistance in the water. Why? Because the more weight you have, the more water you have to displace. So the slower it will go. So you want something lightweight that has enough power. And if I have 3.3 kilowatts here, that will get me running for like anything between 40 minutes to 1 hour, playing around at pretty decent speed. So now we mocked it up. We put the plastic sheets in the middle of each one. You can kind of see them here, and I actually oversized them a little bit, so not big enough to have any issues with these when I connect them, but I absolutely do not want them to connect in any way when they are connected in series, because then they start becoming dangerous. Like you can see like this, nothing happens. It's 3.2 volts ish, but when you connect them in series, then you get, let's say, fully charged 3.6 times 10, that is 36 volts. That is usually actually not that high of a voltage. Like you have 12 volts in your car, But 36 volts, yeah, that's still, getting there. But in marine use, the recommendation is stay under 50 volts, because that is when the current will start, or the voltage will break the skin barrier. And that is real dangerous. So also my old battery pack was at fully charged, it was 84 volts. And that was just so stupid, but I didn't know better. But this time we're going to learn from that and we're going to do it right. So if you're planning to do anything for marine use, first try to get these LFP cells or even the new Natrium cells that just won't catch fire at all. These are hard to catch fire. Not impossible, but hard. The NMC ones, those are the ones you hear about with the battery fires mostly. But even better nowadays, Cattle has released their Natrium cells. You can actually buy them on online suppliers, and they just can't take fire. They don't burn. It's just the chemistry won't allow it. So when I was preparing for this, I ran into another snag. It's like snag after snag after snag. This is product development. It's snag life. And as you see here, I have a Qidi box and a new +4 Qidi. And it's not that I'm unhappy with Qidi, as you can obviously see here. They haven't sponsored me or anything. I have printed 3,000 hours on my old Qidi X-Max 3, but I'm having issues when I do really high heat printing with it, so I had to get rid of it. And yeah, it still works for like PLA, but I'm doing ABS mostly because I really want something that is more fire retardant and something that, you know, is more safe and something that holds up better. So yeah, I got a new printer that I haven't unpacked yet. This is kind of a little bit Christmas gift to myself with an EMS that, yeah, my son will probably love. But back to the thing that we're building. So next thing are the essentials. This is called Tuborg Julebrygd in Swedish. This is Christmas beer. So let's take one of these and get a BMS in here. I actually have a BMS, and then we can talk about how to start connecting these. Okay, that one came falling down just when I opened up. That was kind of funny. Anyways, I have opened my Julebrygd, so it's a Happy New Year to you. I needed that drink, and let's look at the components that I have. I have the batteries. I have glass fiber tape, since that's gonna keep this real strong together. I have, I'm gonna have a 3D printed box around this that I have designed, and that I will now make a little bit smaller because I have a smaller, well, not that much smaller, but smaller 3D printer. I have a bit foam that I will have under the batteries to, if the boat goes like this, I don't want things to destroy the batteries, so I'm gonna have a little bit foam under just to make sure. There's 2 strips under to take a little bit of the, yeah, to be a little bit damping. I have a copper bus bar, and why the hell did I buy this small copper bus bar? I don't even remember. I ordered this quite a while ago, and as you can see, this isn't gonna be enough. So I need to find one of these, and quite quick, if I want to get anywhere with this battery pack. Well, you could also buy like bus bars that are like 300A rated. But they're kind of expensive. And I might just order them from China because, I mean, just a piece of this of copper, it starts feeling like I'm holding gold. It's damn expensive. Like this is like, I think if I buy it locally and I buy the bus bars themselves, it's like $16 a piece, and this would be like 4. 1, 2, 3, 4, yeah, maybe 5, 4. So this would be like $60 if I bought ready-made copper bus bars. So it's much easier to just cut them to your size you want, buy like this from China, and you get them at least reasonably well priced. And yeah, sucks, but yeah. Anyways, my father-in-law is coming from China in like a week, so maybe I'll just order there and send it with him. Then I can get it quickly and cheap. 2 combinations I really like. What do we have next? Well, I have a few of these, and then I have 3, just to talk about a little bit about the difference here. So you can see this is 100A, this is 200A, and this is, I think, 150. No, this is 100A too. So this is where do we put them? Well, we put them on the last pole. I think it's the minus. I had to double check. And the reason is you want the fuse as close as possible to that one, is that if you get a short for anything, you could, I have read books that said, you know, you're working with this and then you drop a tool and then you're super careful. And what did I do? I dropped the fucking tool straight onto the plus and minus, and luckily it didn't get stuck, so it didn't explode. This was not the lithium battery. This was in the good old days when I was having a big sailboat with a standard AGM batteries, but still, you really want something to be, I would actually buy a pole one, I think, here, that you actually connect straight on. But I don't have that. Maybe I'll order that if I order things from China. But anyways, so you want a fuse here. So if anything shorts out in the loop from this one to that one, you really want the fuse to be able to catch it as close as possible there. So let's say what we have. We have three. We have 200, 100A, and then we have a 200. So before we size this one out, let's go over. So I have one for my friend, actually. This one is for him. This is a 120. You can see, if you don't read Chinese, this is continuous 120 amps, and max you can do 240. So in short burst, maybe for 10 seconds, you can pull 240 amps. And on a 3 kilowatt battery, that would mean like 7-8 kilowatts. That's actually a lot of power. But that one is actually the smaller one. I have actually quite a few of these. I found this one when I was just doing some cleaning. And if we take this one, this is actually also a good brand, JKBMS. I really like those. And I'm going to tell you why. You can see that you can have up to 21 cells, or Arsuan Xian, I think it's called in Chinese. So it's 200 amp. And that's not the max. This is the continuous rating. So this one is better. So probably this one has a way higher peak. But that means that I can continuously pull 200 amps from this one. And since they can pull 300 when they were new, I'm actually not going to do that. But that would mean that I could actually size this a little bit like this. They could theoretically, when they were new from the factory, they would be rated safely for 315 amps continuous. That's really cool. But they are used, so I do not trust them. So I will take it down to 200. So then I'm going to put a 200 amp fuse there, maybe? No, on the minus, I think. Like that. And then, on the other hand, I will put this one, JKBMS, that is also 200 amp rated. But I can do one thing with this one, and I can tell it to, since you can use, this is Bluetooth connected, you can actually tell it to stop anything when it reaches, it will cut at, let's say, 180. You can't really trust these either, so it would actually be better to have like 250 here. But I'm going to put this at 200. And then I'm going to have this one at 180. And that is because the components will fry earlier than this one. And I don't want the fuse to blow before the electronics. So I want that one to break. And if something short circuits, you might think that it says, when it goes over 180, that it will just cut everything. No. If you short things, things might start burning. So I want something, if it ever goes over 200 amps, I want the mechanically to cut it off. So, and this is important. If you're building these kind of battery packs, make sure to use a fuse. This is not optional. This is absolutely critical. So we're going to put that there. And we're going to put this one somewhere. You can see B minus. Okay, so it will be most likely the opposite. Actually, I think I'll put them on the same side. So, like that. And where is the better minus? Yeah, so these ones will go up here. Like that. And I will have some kind of plate around this. And then we'll have all of these ones. What are these? Well, they are the cables that we connect from the BMS to see that these are actually working well. And that's pretty much it. So what can I do now? Well, I think I can actually start using the glass fiber tape to put these into compression. So at least we'll have something that looks like a battery pack. I can't connect them yet, but with a glass fiber pack and this one, I could probably 3D print some kind of distance here that I could have here in ABS to put it nicely. And if I 3D print it, I can also create these holes here to kind of mount it on nicely like that. And if I oversize it, I don't think I'll oversize it for this time. But yeah, that should actually work quite nice. So let's do that. Let's put this into compression now, start building the pack. And well, of course, before we do that, we need to check that they are actually okay. And the first thing we're going to do is to just check the voltage and see that they are at the same voltage. Now, do they need to be at the same voltage? No, not necessarily, because the voltage just adds up. If I had in parallel, it would be absolutely essential, because if you have two cells in parallel, like let's say I put another row here and I put these ones in parallel, I mean these two in parallel, which means I put minus and minus together and plus together, and then I would jump to the next row. Well, then it would be darn super important that I did have them exactly at the same voltage. So these cables, they will be connected to each plus here and to the last minus. And what it will do is that it will sensor the different voltages, and then it will balance them. So instead of me doing the balancing, which I had to do by using my other instruments here before, now I don't have to do that. I'll just let the BMS measure all the differences and then start balancing them out. That will take like a day, I think, because it's 1 or 2 amps max that it can. I mean, if this one is like say 3.3 and this one is 3.2, then it will take current from this one and move to that cell, and everything will be balanced out. So I think, yeah, let's go and test the batteries and see at least what voltage they're in. So they're at least in a good 3.2-ish voltage. Okay, so I have now measured it with my multimeter, and I put it to the DC mode to check the voltage. And all of these are like 3.3 something, except this one. And this one is the one I got in my first batch. So this one is lower. I might actually do a little bit testing here before. I'll actually charge this up, I think, alone with a constant DC power supply to at least 3.3, and then wait a few days to see if it falls. That was the one that came with those that were destroyed. So it's also, I mean, I got them quite a while ago, so they were sent like in November, so they could have fallen a little bit, but lithium cells usually don't fall that much. So yeah, I don't know what the state, I mean, they might have just been charged to different levels, but I do want to make sure that it doesn't fall. And since I have to wait for more components, I have to get the 3D printer going, I have to 3D print the whole thing around. It's pretty smart to do a test here and get it up to 3.5. I can also do it outside, although it's cold. But I can get it up a little bit and see that it's fine. So that's pretty neat. But otherwise they seem to be in really good shape. So yeah, let's charge this one up, and I'll probably open my little 3D printer, and it says glass fragile. I really hope they didn't destroy that one too. I'm so tired of getting things broken when they get here. So before I end this video, I just want to show what I'm doing. So like I said, this one was this battery that came unhurt. You can see it's kind of in a nice shape and it has no dents or anything. And I just wanted to make sure that before I put this in series with some other battery cells, that it's actually fine. So I've been monitoring it with my trusted old measurement here to see that, you know, there's nothing like going haywire or something like that. And I've connected it to a direct DC current. So the way I did this was to first use the multimeter to check the voltage from the cell. Then I turned that one on, but not those two on. I actually connected to see that whatever is on that display there was actually what I was measuring out here. And it was with this mini tiny difference, which is kind of, you get the voltage drop through cables at this. So yeah, that's how I do it. And then I made sure that they were exactly on the same voltage, and then I just cranked it up a little bit. And with these, you got to be really careful, because if you just do it, I mean, that one goes up to like 100 volts. So if you just move a little bit, it quickly goes up, and you really do not want something that is a big voltage difference. I mean, if you go to 3.7, 3.8, yeah, who knows what will happen. But I mean, LFP cells are usually quite safe. But you can also see the wear and tear I was talking about, right? imagine this being your protection against against the short. Actually, yeah, I'm thinking if I had more of this plastic, I would actually take this away and then put new on. But I don't have it, so I'm gonna put a big thick barrier of plastic instead in between. So before I end, I also want to talk about a little bit about the boat. I built an outboard, I 3D printed. I built carbon fiber. I mean, inside you have wood core, then you have carbon fiber, multiple layers skinned around that, which makes this super strong. And then I have 3D printed plastic to get this airfoil. It's not super great, but it's okay. I didn't know too much about airfoils when I started out. Now when I'm doing flying and reading lots of books about how to build airplanes, yeah, it's more like a Clark Y, I think, if you are into those kind of things. But this, I don't think I'm actually going to use this boat I have. I have a rubber boat which can take like 4 people on an ocean, but it's really heavy, like 50-60 kilos. I cannot even carry it myself. And this one, that's a 20 kilowatt motor. But it has its benefits. So what I'm planning to do next is actually a bit different. So don't worry about that. No, nothing weird in that. That's just water. I think that this thing that I built with carbon fiber here and plastic, it's just not gonna work out. So instead of trying to continuously improve this, what I'm gonna do is actually, I'm gonna use it for my son's boat. It is totally oversized, but it has a few benefits that I can do here. I can just bolt these off here. I can cut it here and keep the wood core here and just bolt it straight onto my son's boat. And sure, he would have a 20 kilowatt motor, but that motor has been tested. I've been out driving it with several people. I have a protection here. So if he would somehow touch anybody, there is this 3D printed protection here. If he runs aground, this will first take, and I could make it so that if it actually hits the bottom, it flips up. So I could put it on a hinge. So if my son would be driving, yeah, I mean, this one could go ultra fast if you have the right battery pack, but I'm not going to put that one on. Maybe in the future when it's bigger. It's kind of future-proofing it all also. But anyways, what I want to do here is, one of the problems with this large thing is that it has a huge moment arm. And the moment arm is, you know, like if you take a prong and you move it and you have a long arm and you move it, and then the force you get out here through the tipping point becomes huge. And the same thing happens here. The distance from here all the way down here, there's a huge moment arm. And I don't need that. So if I just put the end of the boat here, so it just make sure that the propeller here is under the water, I get the moment arm from here to there. And that solves all my problem. Actually, I will cut off all the way here, there, somewhere, and then cut there. And then I'll just keep this part. And then I put the electronics in the boat. So that means my son would have 26 horsepower electric engine on it. But the cool thing here is that I have a 300 amp BMS in here that is water cooled. ESC, I mean. And that means that I have tested this, I know it works. I have also this one, so I can increase. And if I drop it, it goes to 0. So I could kind of build a steering wheel out of this on the boat. I don't want to have it like this, like an outboard. I want this to be totally fixed. But so I can have the electronics here to control the speed, but I can have what do you call it? Oh, I'm a bit tired here now after being here a few hours. The steering of the boat, which is going to be disconnected from this, that can be just on this one. So yeah, I think that will look really cool. This is also carbon fiber here I built on a steel tube. So that's going to look pretty neat, right? So I'm abandoning the 3D printed jet boat outboard concept. I think it's really cool. If anybody wants the drawings and want to continue on that, you're welcome. You can even get my 3D printed aluminium part, since I'm not going to continue it. And yeah. Anyways, thanks for watching. Cheers.